Hi guys, I'm Jack Samick, class of 2014, and today in this video I'm going to demonstrate to you how to find the area not under the curve but between two curves. Alrighty, so you guys already know how to find the area under one curve lining up with the x-axis. So if I were to draw it out here, what you guys already know how to do is here's your y and your x-axis, and you have a curve that goes like this, and it goes from point A to point B. And so what you guys know how to do is you do the integral from A to B of f of x dx, and what you guys know is that gives you the area that is all in here. Let's draw another y and x axis here, and again from A to B, but this time you're not just finding the area between f of x and the x-axis, you're finding the area maybe between f of x and g of x. So this one down here, we'll call this guy g of x, and we'll call this guy f of x, much in the same way that this guy was f of x up here. And so what we're going to try and find is the area between these two curves. Let's take the area from the top curve, which is everything down here, which is what you're looking at here, and let's subtract everything below the bottom curve, g of x, and then that will give us this middle area, which is f of x minus g of x. Just like we mentioned earlier, we are going to take f of x and subtract it from g of x, except we're going to be doing this in integrals. So we're going to go integral from A to B of, we always want to go from top down. We want to take the higher one up and subtract it from the bottom one down. So we're going to go f of x, the integral from A to B of f of x dx minus, because we're subtracting, right, minus the integral of A to B, because we want to keep it within these same constraints here, A to B, except we're going to be subtracting g of x dx, and that will give you that middle area right there. So we're going to do an easy practice problem so you guys can kind of get the hang of it. So a question that you might see might look something like, let's make an example here. So you have an example, and I might say, find the area of the given region bounded by f of x equals x squared and g of x equals root x. So you guys have seen these types of equations, these two graphed together hundreds of times, right, by now. So basically what we have here is we have x squared, which is going up like this, and then we have g of x equals root x, which is going slowly across like that. So when looking at this, oftentimes it won't give you points between which you want to do it, in which case you're going to go from the origin, 0, to where they intersect. So on this graph where x squared equals g of x, you know that they intersect at 1. We know that because we've seen these graphs hundreds of times, but in the event that maybe you got more complicated problems, you would set these two equal to each other, and then you would go from 0 on the integral. You'd go from 0 to whatever that number is where they intersect. So here we know it's 1. That makes it easy for us, so we'll put a little 1 down there. So, now we have to identify now which is on top and which is on bottom. So within our restraint here, what's going to be on top is f of x. This is the top part, and g of x is on bottom. So we're going to be doing the integral from 0 to 1 of f of x minus the integral from 0 to 1 of g of x. And so what that's going to do for us is it's going to subtract all this stuff down here, and it's going to give us what we want is that inside section. Alright, so let's do the math now. So as we explained before, we're doing f of x from 0 to 1 minus g of x from 0 to 1. So we'll write that out. We'll go the integral from 0 to 1 of f of x minus, and because they're both going from the same spot, 0 to 1, we can just all put it within the same integral, and then we're going to do minus g of x dx. Sorry for the sloppy handwriting there. Alright, so I had to sit down because I was standing and it was getting hard to write. But basically what we have here is we have this integral, we have f of x minus g of x, so we're going to go, from 0 to 1 of x squared minus root x dx, and then we are going to solve that. When you do out the math, you're going to get 2x to the 3 over 2, because, right, we're just doing integral, we're adding over, divided by 3, and then what we're going to do is minus x cubed over 3 as well, and then we're going to go from 0 to 1. That doesn't change, and when you plug in all of that, what you're going to get is it is equal to 1/3. So, of course, I'm skipping a lot of the small math, but it's because I'm assuming you guys already know how to do that, and we shouldn't waste time. So there you go. That is how you find the area between two curves. So just as kind of a review here, key things that you want to remember: you want to find which curve is your top curve between your 2 points. If you need to find which points those are. Oftentimes it will be the origin and then another point of intersection. So you find the top curve, you locate the bottom curve, you find the integral, the area under the top curve, and then subtract the integral, which is the area under the bottom curve, and that will get you that middle section. Have fun.